Welcome to May's ECR Wednesday webinar. Today our speakers will discuss alternatives to the traditional journal article. The webinar will begin with the panelists sharing their stories. Then, in the second half of the webinar, we'll be putting your questions to them. To ask a question, you can type in the question box on the GoToWebinar Functions panel, or you can tweet us. We are at Eli Community using the ECR Wednesday hashtag. Please also join us on Twitter immediately after the webinar. We will be continuing the discussion under the ECR Wednesday hashtag. Finally, I'd just like to let you know that we are recording the webinar and will make it available on YouTube in the near future.
Thank you, Emma. Hi, everyone. Thank you for joining us today for our Early Career Researchers Wednesday webinar on alternatives to traditional journal article as a minimal unit of productivity. My name is Vinod Elangovan. I'm a postdoc at Max Planck Institute for Biophysical Chemistry, Germany. I'm also a member of Early Career Advisory Group of eLife, and I'll be moderating today's webinar. To give you an introduction about eLife, eLife is a nonprofit organization founded by three major research funders, the Harvard Hughes Medical Institute, the Wellcome Trust, and the Max Planck Society. And recently, eLife is also funded by Wallenberg Foundation. It's an initiative that's led by scientists for scientists in order to recognize and promote responsible behaviors in science that doesn't emphasize impact factor, but rather tries to expand and enrich the concept of research impact. eLife also makes it a point of priority to support early career researchers. And for the past 4 years, we've already had the Early Career Advisory Group, and I joined last year. The call for this year was just closed 2 days before. And everyone at eLife is also aware of the pressures of publishing among the early career researchers, and this is one of the reasons why eLife is supporting early career researchers tremendously. I'd like to now welcome our three panelists today. Guruji Doyle from Refigure, Lawrence Rajendran, he's a professor in University of Zurich, and he's also the Chief Executive Officer of Science Matters. And we also have Courtney Söderberg. She's a consultant at the Open Science Framework. To set grounds of this topic, so the purpose of any scientific article or a journal article is to communicate results, but this is also considered as a measure of productivity for individual researchers in decisions such as hiring, promotion, and tenure. And this makes it very difficult for the early career researchers to navigate such structures where one has to publish and then has to get a job at the end. And although there are several advancements that has happened through internet, the whole scholarly system or the publishing system has not evolved much until very recent times. And the structure of these articles are usually preserved because you have the introduction, methods and materials, and results and discussion. That's very well preserved since 400 years. Maybe these days we do not print journal articles on paper, and we do not maybe call them as papers, but they've dynamically evolved. But we still have the structures that's very well preserved. Now, in this webinar, we're going to also see how alternatives to traditional publishing would also reward early career authors, or any authors for that matter. A few of the innovations that have happened in the recent past, I will quickly mention through. One of my favorite is Journal of Visualized Experiments. That is because as a medium, one always has written text, and all of a sudden, with the power of internet and videos, one could disseminate information about how protocols or how methodologies are made, and that is very effective. And there are also other innovations such as dynamic data sets, which can be visualized using Faculty of 1000 research. And there's also citable reviews, which Faculty of 1000, eLife, and several other journals have recently started doing it. There are also other initiatives such as annotation using hypothesis, which is also supported by eLife. If you haven't tried it, you should perhaps try it. And there's also things like micro-publication, Science Matters, Refigures, and Open Science Framework, three of which we will actually hear today. Now I'll like to introduce the first panelist, Guruji Doyle. She works for, or she is a co-founder of Refigure, and she'll tell us how Refigure is shaping up everyday science that doesn't usually get published.
I would like to share my slides, if that's okay. Hi. Yeah. Can you see my screen?
Yes.
Okay, excellent. Hi, so I'm Girija. I'm an early career researcher myself. I'm a postdoc in biological sciences. And as I will explain in my next slide, I realized that there was work that early career researchers do every day. We are productive every day, but it can take years to disseminate that information. So along with my my Baymate, James Joseph Aiken, I founded Refigure as one way to address that need. So this is my daily cycle and of many of my colleagues in biological sciences and other sciences, where I read, discover, and interpret literature. Based on that, I design hypotheses and I conduct experiments, and then I analyze those experiments in the context of my reading and my knowledge. And this cycle is repeated hundreds of times before any engagement with the publishing industry happens. So any engagement with editors, journals happens. But throughout all of that process, I'm actually producing outputs that could be useful for colleagues in my field, as well as that could show my productivity. So Refigure is a tool that can be used daily to save and highlight daily insights, whether through reading or experimentation. So with Refigure, we wanted you to be able to save figures as you're doing your reading and connect figures in dashboards where you can share your insights. So I can take a figure from 3 different papers, maybe figure 3 from one paper, figure 7 from another paper, and maybe I'm saying that they are testing the same drug or they are working in the same disease, and connect them and create a collection which is useful not only for me but also for my colleagues. I can keep the collection private or share it. I can also, in the same scheme, actually connect my incremental data that I got today, last month, maybe it's reproduced data or negative data, to published findings. And again, I immediately share my data. I can get feedback and can help other people advance their experiments by doing so. All of this is done at refigure.org, where the dashboards are displayed, and the collection of the data is through single clicks. You can click on a figure you want. We just finished our beta testing, and that was limited to PubMed Central. So any figure on PubMed Central or Figshare, eLife, and PLOS. So those 4 places, and now we are expanding to all open access journals. I would like to take a minute to thank the support that we've had, particularly from eLife, who partially funded the beta product, and as well as from our many other collaborators. And I will just take a minute to show you what a refigure looks like. And so this is just one of our most visited refigures, where somebody has actually collected data from published, two different published studies from the Cancer Reproducibility Project to see how the reproduced data and the original data look side by side. And you can view it. As you can see, the legend was captured, the authors, the article, and you can also provide your own commentary. That's it from me.
Thank you very much, Girija. Now, I'd like to invite Lawrence Rajendran to share his views about how storytelling in science has impacted for several years and why storytelling needs to be avoided and each data point needs to be valued much more. Lawrence, please.
Hi there. Hey, I'm Lawrence Rajendran, as Vinod already introduced. Thanks, Vinod, for organizing this webinar, but also other panelists. I think it's also extremely interesting to listen to Girija. I think the reason that we started Science Matters is because of many different aspects, and one of the main things is that there is a lot of storytelling in science. And when you think about storytelling, or there is a narrative, there is a little bit of fictional aspect that we attach to storytelling. And science, on the other hand, when we think about science, it's largely a fact or hypothesis and not much of fictional element in it. And then this is exactly what we fight against, in a way, that there is so much of entirely against the publishers or the universities and the academic institutions that require this story-based papers that are published in these high impact journals. But also there is a desire within us to tell stories around observations. And I think this combination of a desire to tell stories from the individual as well as the demand to have a story-based paper when you have to publish, I think this does corrupt science to some extent. I don't say that narrative-based publications are largely incorrect, or but it does somehow embellish the actual truth. So we do prune our narrative. We remove observations that do not fit a narrative, and so it starts from this massaging of data. This not necessarily this the other end of the spectrum, which is like manipulation and frank fabrication. But really, many of us do think that in order to tell a story around an observation, we have to prune our narratives, and so we start with a wonderful hypothesis. Usually in any field of science, either the hypothesis comes from an existing study, or we make an observation and then we make a hypothesis. But then when it comes to publishing, then we need to contextualize our hypothesis. We need to contextualize this observation, and we need to bring in all these elements in order to tell story. It is not so bad when it comes to a desire to tell stories. And I think the reason that I go to the lab every day or any researcher who goes to the lab, is really to figure out what are the next steps. But our question is, should we submit stories already from the beginning? Can't we have a Lego-like model of narrative publishing as we go? As is there a possibility to extend these narratives as I do these experiments, and as you go, can we have these narratives established in the scholarly space? So Science Matters basically is designed as a platform where an author can start with one observation, and this observation gets you make an observation, you make it right, in the sense like you have enough of statistics. It's not as one-off observation you just see one time and then you can publish with Science Matters. Science Matters is a serious journal. It's a peer-reviewed journal. it's like a figure one of a traditional paper where you make this observation, but not just one time, but many times, as well as from many different angles, different methodology, different cellular systems. But that talks about this one particular phenomena. A leads to B, or A is B, or A does that, and then this gets into we perform what we call as triple blind peer review. Since it's a single observation, we can make it anonymous, and so this is sent to an editor who doesn't know who the authors are. And I think because this is extremely important that the scientific content is peer reviewed as opposed to the identity being peer reviewed. Today there is a mix of all of that. That's the identity of the institution plays a part, the identity of the author plays a part, and scientific content does. And we think that scientific content alone should play a part when it comes to evaluation of science. And so we perform what is this triple blind review, where you have the editor, the author, and the reviewer. They're all blinded to each other, and so your scientific content alone gets reviewed. And we perform what we call there is both a qualitative peer review as well as a quantitative peer review. And it's extremely easy to submit. And we created this portal. You don't have to have a PDF. You don't have to have a Microsoft Word. You drop the data, and then you describe the data in the Science Matters platform. And that is, in what you see is what you get, template. And this is sent to the reviewers. And then the reviewers can perform this review very fast and online. And then something interesting happens with the peer-reviewed data set. If it needs to be revised, it's sent back to the authors, and they revise it. And once it comes back, and depending on the peer review, if it is technically well done and it passes the technical quality, then it gets published in our journal called Matters. This is the flagship journal that any technically sound observation and that is deemed to belong to the scholarly space, we publish this. But on top of it, if the peer reviewers think that it's not only technically well done, but it has these conceptual advance, this paper has some scientific and societal impact, then it gets published in a journal called Matter Select. And this is like the journal that is for something that is that seems to for observations that have higher perceived impact. And so the observations are published outside without any story context. It gets peer reviewed and it's published, and you can come back and extend this observation one at a and you can extend this narrative. But as you see, when you extend this, others could also come back and extend. So if I publish a paper in Alzheimer's and describe a kinase, somebody else could say, oh wow, that gene, that protein is involved in cancer, and the similar mechanism happens. So as a result, there is some kind of a online collaborative, a real-time but a collaborative publishing, and we contribute to a narrative together as opposed to a single author, a single research group directed narrative that this often doesn't say the truth in its full context. But when we collaborate and we contribute to the narrative together, be it as may be, it could be negative observations, it could be positive, it could be reproducible. All of these observations belong to that narrative. So as a result, we think in this way there is a natural emergence of a scientific narrative that is closer to the truth, as opposed to the pruned version that comes from authors and the reviewer demanded. Many times you do see that the reviewer says, oh, this doesn't make sense, this is the negative data, you don't have to. But so this is what we believe. This is what we believe in, and this is what Science Matters does. We exist from 2015, and the first issue was published in 2016 February, and we have now we have fulfilled all the criteria for PubMed application, and we have done this PubMed application. We're waiting for indexing both in PubMed and in Scopus, and we hope that it is fully open access. And that's pretty much what I want to tell you about Science Matters, but I'm open for questions. Thank you very much.
Thank you very much, Rory. Now, we have been so far discussing only about the final outputs or the final products of the whole research cycle, but a lot of things that are in between the research cycle always gets neglected or never gets revisited. Now I'd like to invite Courtney Soderberg to tell us more about how one can use all these in-between research cycle products to be documented well using open science framework. Courtney, please.
Sure. Good morning / afternoon, everyone, depending on what part of the world you're in. So I work at the Center for Open Science, which is a nonprofit in Charlottesville, Virginia, in the United States. We've been around about 5 years now, and the mission of the center is to increase the openness, reproducibility, and transparency of research work. And one of the things we do is we build the OSF, or Open Science Framework. That is a free open source web tool that gives researchers a place to collaborate on, document, store, and if they want to, eventually share the life cycle of their research. And so, as previous panelists have mentioned, the research life cycle is very long. It can take months. It probably takes years from the point where you kind of first have an idea to the point where you maybe submit something for publication. And because publication really, for a long time, was what was driving jobs and tenure and promotion, it lent itself to motivations that might cause this storytelling that Lawrence was talking about, where researchers kind of know what tends to get published and what tends to not get published. And so you're put in this awkward position where you may have strong motivations to try and make it more likely that your study gets published. And we know that certain types of studies tend to get published more than others, specifically novel studies that support their hypotheses tend to get published less than studies that don't support their hypotheses, or that may be replications or more kind of slow incremental work. And so what that can cause is that there can be a large kind of gap in what is published versus how much research actually happens. And even what is published, there may be missing information, as Lawrence talked about. There may be, hypotheses that are dropped or outcomes that are dropped, or maybe kind of a slight retelling of the story. And so this can really distort the information that we're getting about the science that is happening versus the science that we see, because all we typically see is that final endpoint publication. And so one of the things that the OSF is built to do is to try and make it easy for researchers as they go along to deposit the pieces of the research that build into that final holistic piece. So it can take data, it can take code or software scripts, but it can also store images or videos or PDFs. So you can store research protocols or materials and collect those all in one place and then share those out. And all the files get GUIs, globally unique identifiers, and they can also get DOIs. So what that means is that when I, as a researcher, decide to share my work, I can share not only that final write-up, but I can also share the data that underlies that. I can share maybe the pre-registered analysis plan of what I plan to do before I saw my data. I can share the exact survey, maybe if I was doing survey work, so that people can get a better understanding of exactly how I did my study. But I can also share all that information even if my study never gets published. Maybe it doesn't find a home in a traditional journal, or maybe I decide I don't want to go through the trouble of trying to publish it, but I think it might be useful to somebody. I can share that data set, I can share that analysis code as its own individual research output in a publicly accessible location where it has those unique identifiers so that it can be cited and I can get credit for that information. And there are a lot of groups working to standardize citations for data and code and materials so that, just like when I publish an article, when I publish a data set or when I release a software package, I can get the credit I deserve for that when other people reuse that work. Additionally, the OSF also allows for uploading of preprints to some open access preprint servers we have for kind of that intermediate step between just releasing the individual research objects like data or code. And once you have written up that story, but you want to release it maybe more quickly than the traditional publication process will take while you're going through peer review, You can upload it as a preprint, release that. Those also get DOIs that they are citable and will eventually be linked to the final publication if they do get published. And you can connect in that data and that code and those materials to that preprint, either by uploading them with the preprint directly or by using the unique links that we generate for all the files to embed those so that people reading the preprint can get to the data or the code. And so what this allows you to do is kind of, as you're doing the research, start to create and store the cycle of that research and then share that cycle. So you're not kind of 2 years after the fact trying to recreate all of that while at the same time you're trying to go through the publication process and then only do that for things that eventually get published.
Thank you, Courtney. And I'd also like to thank all the panelists for bringing in their ideas. Now it's time for questions. Audience could type in the panel, question panel in the GoToWebinar functions, or you could also use eLife community and use the ECR Wednesday hashtag to ask your questions. Before we receive questions from the audience, I had a question, which is we are also talking about unit of productivity. So when we publish these single data points or single observations and findings, how would it be made recognizable by the hiring committees and so on? Is there any ideas from any of the panelists? Sure.
Sure. At least in Science Matters, there's every single observation. So this is pretty much like how we published in the 1920s, 1930s. A Nature paper at the time would be cloning of, identification of this enzyme or isolation of this enzyme, and then we would have this other and an extension through another as another paper, or biochemical or biophysical characterization of these enzymes. So Science Matters articles are peer-reviewed and it's single observation. So it is something. So it is a publication and it has a DOI and it will be, in these indexing index. So it's not different in terms of when it comes to hiring committees. You can put whether if it's a Matters article or a Matters Select article next to your Cell and Science Nature paper, and that belongs there. So you should tell them that this is a product of your intelligence, your hard work, and it needs to be in the public. So it's also an open access journal. So I don't see any difference when it comes to listing them as units of productivity in your CV, when it comes to presenting them in conferences, etc. And I think this is extremely important that it also that the policymakers and the funding agencies as well as the recruiting committees recognize these alternative forms of publishing as also units of productivity.
Yeah, and this depends a little bit by field, but I am starting to see, at least anecdotal evidence, more and more of hiring committees starting to specifically put in their job ads wanting to see evidence of open science practices, so publications of data, publications of materials. But I've also heard from a couple of people I know, and my background is social psychology, especially for graduate students who are going into postdocs or who are going into their first academic job. A lot of times there will be the papers published in these places, and then there may be a couple of those in-prep articles that you put on there because you want to show work, but they're always kind of nebulous, right? You don't know how much work has gone into anybody's in-prep. It's like, do they have an outline? Are they about to submit? And I've heard from some people on hiring committees that if in place of an in-prep, somebody says, yes, this is in-prep, but here's the link to the preprint, then the hiring committee can actually go and see, wow, okay, this is where this is. I can read this. I can kind of evaluate this better than just this amorphous in-prep. As Lawrence said, I think the important thing is whenever you're releasing these kind of research outputs that aren't the traditional journal article, it's just important to make sure that you're releasing them somewhere where they are accessible, and where you can give them the proper sort of metadata. So a unique identifier like a DOI, ideally a license. So, not just posting them on your personal website, but looking for a repository of some sort, whether it be OSF or Figshare or Dryad. There are a ton of them out there, just so that you can get something that is citable and findable to make sure you can get credit.
I would like to add to that, when we say hiring committee, we often envision academic hiring, but I would also like to provide the perspective of, you're not going to academia, and you are saying you often get hired not for what your big picture project was, but what your techniques are and what your ability to connect things is. So maybe I worked on this gene on cancer. It's highly unlikely that if I was going to industry, I would be exactly working on that gene. They want more my expertise. And there is a very good place for non-traditional outputs to show that, I can actually do this. You don't need a whole paper to show that you know about cancer or you know about a technique. So that's one comment. And the other thing is change is coming. And I think as the newer generation, if we feel hesitant about showing these outputs, then you can't expect that funding agencies and hiring committees will accept them. So I always encourage people to have those outputs on your CV. So once you have them, that's when you get into a conversation. But if you don't have them at all, then you don't. For instance, in the United States, in the NIH now, there's a clear place for indicating preprints. You've done. If you've done so non-traditional outputs, if you have taught a course, if you gave a talk, and things like refigures, you can include all of them in your grant application. So if you have traditional publications, that's great, but don't neglect your non-traditional outputs.
Thank you very much for that insight. The next question that I actually wanted to ask was about when you have persistent identifiers such as global unique identifiers or digital object identifiers, what role does the indexing system plays? Because once you have these unique identifiers, then you reposit them at the right place. How would that, integrate into the system of alternative publishing?
I can start as a simple sort of, we are from the other side. We said we wanted to take the smallest thing that people are doing daily. And why does refigure need DOIs, for instance? And the reason we do is that if you want people to take that smaller unit of productivity seriously, it has to be connectable. So for instance, if I want to cite it, how do I cite it? So that's one major concern. And of course, sort of archiving of data, right? And version control. So I'm speaking, not from the perspective of people who know much about DOIs, but more as why did we need it when we started thinking about this?
Yeah, I think the DOI can serve two purposes, as was mentioned. One is to make sure I can get credit, but the other is to make sure that, if I'm going to reuse somebody's data set, that I am definitely working with the right data set or the right version of that data set. I think the landscape of how DOIs for these different types of outputs are used is changing. One thing that we've seen start to happen recently is, I believe it's Crossref, is working to better match up preprints with the final version of the paper if it ends up getting published. because oftentimes those will get two separate DOIs, and you want to be able to knit those back together at some point to say, the citations that went with this preprint maybe also belong on this published article because they are related. And so that's starting to happen over the past, I think, few years, though that it may be more recent than that. But we are seeing movement in how these identifiers are being used outside of just citation to knit these different outputs together into these holistic pictures.
If I can just, just a sentence is that I think it is really changing, and the digital innovation and the fact that if I want to look for something related to a scientific question that I have, I oftentimes you go to Google as opposed to just going only to PubMed. So it is kind of changing that we used to use Medline and PubMed as the only source of information, scientific information, but now it's changing. There are initiatives such as Google Scholar, and there is initiative as Meta AI and Crossref. I think we will, DOIs or any identifiers themselves might be enough in the long run.
Thank you. Yeah, there's a question to Courtney. So what is the general perception of scientific community in sharing data that has not been published yet in a traditional journal? What about the risk of getting scooped or someone using your work without getting cited or credited?
Sure. I mean, this differs a lot by fields, different fields, kind of the norms are changing at different rates. I know in genetics, a lot, NIH in the US changed its standards along a few years back, probably more than a few years back at this point, where, if you get funded by them, X number of years after that funding, you have to share your data, because there was this understanding that the data that is collected is kind of more valuable in its entirety. If we can collect up all those pieces, we get way more information than if those pieces are kind of only accessible to the people who collected them, which is part of this growing understanding that data is this very valuable first-class research object. The thing I will tend to say about scooping is that if you are the person who collected your data, you probably know it better than anyone else. Even if it's incredibly well documented data, you kind of know the ins and outs of that data. So different people have different points at which they feel comfortable releasing their data, but even if you released it, 10 days after you got it, you probably have a head start on anyone else. That's not to say that that purely prevents scooping, but I think that can alleviate some fear. But I do know a lot of people who don't release the data until a publication or until the end of the grant, but they do release it, and so kind of that's fine. It's just a comfort level. Whether you are definitely going to get credit for it, it's kind of the same as citations for papers, right? It's if somebody is writing a manuscript and they're building off of your work, they should cite you. Is anybody going to sue them if they don't? Probably not. So kind of the same thing goes with data citation. You should cite when you use somebody else's data or their code. But I think it goes more on the norms of the scientific community rather than anybody is going to go and sue somebody if they don't.
I would like to add that, you can start, if you're worried about scooping, you can start small. We have spoken to hundreds of researchers now. About 50 to 80% of your data is not going to make it to a traditional publication. This will be reproduced data, negative data, the actual numbers behind an experiment. And you tried an antibody today, it worked or didn't work, share that data. It tells people you know that technique, and there's no risk of scooping there unless you're worried that people will find out what target you're working on in that example. But there's lots of data that we generate daily that has no risk of scooping associated with it, but it is an output. It is you were productive, and I think it's important to share. And that's the thing. You may think it's unimportant data. The person in another person on the planet somewhere needs that information, and by holding it back for fear of scooping, you're actually in a way retarding the progress of science.
Our audience have been very enthusiastic with alternative methods of publishing. And there's a question concerning smaller units of publication. Do the panel see any issues with trying to establish this small units of publishing as new standard way to work, forgetting about the problem of journals being silos for the moment? We are a new digital world, so we don't need journals.
May I?
Yeah, sure.
So, I think in the long run, when knowledge, scientific knowledge, is now it uses technologies like blockchain, where it immediately your data gets timestamped, your observation gets published, and everybody knows about it. I don't see in the long run that we need these traditional forms of PDF collections that we name them journals. That needs to exist. I think in the long run, probably we'll go into this mode where we either publish these smaller units of observations as you conduct your experiments and research, or if you're one of those people who love to tell stories and you love these narratives because there is an internal desire, not necessarily this external pressure, then you would probably publish this as preprint because you want to tell the world a narrative. And even in that case, the preprint could use technologies like blockchain, where you would timestamp or we would have crowdsourced annotation, or even peer review, where you have badges, where you have the quality is attached to your preprint. As a result, I really don't see the necessity for preprint. And so I think there's also similar ideas from several angles, and Mike Eisen also presented something in this direction, but not on blockchain, but in this direction, that preprints could contain information about peer review, and that essentially denecessitates the need for traditional journals. So I think I really don't believe that Science Matters would also exist after some time, because now Science Matters is moving towards utilizing blockchain, which is basically using peer-to-peer transaction of research value, which means that we, even as middlemen, shouldn't exist. And that's my goal, that Science Matters doesn't even exist after some time. I'm actually, right now, I'm in Bucharest, sitting in the home of the co-founder of Ethereum, but trying to figure out how we can leverage blockchain, which would do this peer-to-peer. And when we have achieved that thing, that where a scientist, as an author, I submit something in the scholarly space, it gets timestamped, it gets peer-reviewed, and then it's published, I don't really see why there should be something like an intermediary like journals. There should be publishers.
I have a slightly different take on it. I know there's a lot of push behind blockchain, but I believe Mark Patterson from eLife had a recent blog post about it. If you think of publishers as service providers in the days when we used to write or print long papers, perhaps one way to look at it is that the service the publishers will be providing, they will innovate. Right? Sure. So perhaps we will continue. Maybe the publisher is the one who's providing the blockchain technology in this example. But I don't see in the long run why minimal units could not be adopted more widely. And what you will see is that the role of publishers is perhaps changing over time.
it's similar to how Bitcoin changed the the existence of financial intermediaries. And we thought we wouldn't need banks. We don't really, with blockchain, you don't need it. But what did we see? Now in 2018, there are banks that they want to implement blockchain to have transactions. I think you're right. Publishers should, and maybe they will adopt these technologies, but we can also have without. There could be a clear, direct peer-to-peer transaction, and maybe publishers will come up with. I think one of the things we could have is really not necessarily primary article publishing, because I think the more and more minimal units would be observations data and micro attributions, micro publications, or hypothesis that is getting published in the open access open space. The traditional traditional journals could become more of a review, a big picture, so collection. You bring all of these different data points from different sources, from Science Matters, from Refigure, and all of that, and then put them together and say, I'm going to give a new perspective. This is more like a perspective review, traditional journals becoming review journals, as opposed to traditional journals publishing primary articles.
Okay, thank you for that view. Moving on with that, the story narrative, which people are mostly fond of. There's a question on whether the next step of publishing would be about publishing our department seminars. Would panelists like to add something on that?
That actually?
No, so how would the future of publishing be publishing department seminars? Because most of what the research outputs that we see are outdated around 8 to 12 months. Mostly research, the departmental seminars would have very fresh data. Would that be a way to move forward?
A departmental seminar is you giving a paper in verbal form with pictures. So I don't see why not.
Yeah, and I mean, we're already seeing this trend of more and more conferences suggesting people putting talks or poster presentations online, shared. OSF has a service called OSF for Meetings, where you can send an email with your talk slides and it gets put up into a project that's then open and signable. And there are other services that do that as well. And so I think we're seeing people starting to share earlier and earlier in the process, because they kind of realize that if they want to get their research out there, if they want to get kind of feedback earlier, sharing earlier really helps with that. And the minute you put together a poster or a set of slides, you would put something in a consumable format that kind of has all those pieces and parts that people need to kind of understand, okay, this is what you're doing, this is why you're doing it, okay, I can look over that and maybe provide some feedback or use that as a jumping off point to realize that, oh, I'm kind of doing something similar, and maybe there's a collaboration there, or maybe I want to build off that work that's actually still in progress, but suggests interesting new avenues.
So one key difference between a departmental seminar and a paper is the review. When you have a copy either on your computer or printed on paper in front of you, and you think deeply about that data, is when you're able to sort of craft a review around it. So one way to look at departmental seminars is they are preprints, and if you publish it, then you invite peer review on it.
Thank you very much. And we have the next question, which is also a bit futuristic. What is the evolving role of video in scientific publishing, like what you're seeing with Case, View Media, and others? Does anyone want to?
So one thing I've started to see is people actually uploading videos of them doing the protocol of their study, usually on, maybe it's not the entire study, it's kind of a representative, here's what this looks like. Because a lot of times you can't necessarily you can write down kind of what you did, but having a video may provide details that you didn't think of to write down. It's not something that I've seen anyone say, like a journal or a funder say, yes, you have to do this. but it's something that I've started to see in psychology and biology, and I think it can be really helpful when you're trying to, in detail, understand exactly what happened in that protocol. Having the video along with the written protocol can be really nice.
Vinod, what were the examples that you dropped off at the end of your question? What were the examples?
One that's called case. The other is VU Medi, which is VU Medi. I've never been familiar with that. This is a question from audience. So maybe we could also take this to a Twitter chat once the webinar is over. But there's another interesting question. Would you share data or results from a failed experiment, which is basically technical mistake? If so, how do you make the difference between real results and the wrong results?
So I work at the bench a lot. This is actually a situation I face, having founded Refigure. There's always this question of, do you know for sure did you made a technical mistake?
Yeah.
If you did, and you can definitely tie your failure of your experiment to that technical mistake, I think it's often valuable. Protocols sometimes were written 20 years back, and there's, the buffer has to be dribbled a certain way or something, and some of that is not necessary. And perhaps if you chose to skip a step and it worked or didn't work, it's useful information. But very often it comes down to, I think I did this, I think I made a mistake, or I didn't. And we think about that when we don't get the result we expected, which I think introduces a bias.
Yeah, I think, oh, go ahead, Lawrence.
No, go ahead.
I was just going to say, I think it's, we have a lot of cognitive biases that can play kind of havoc with our memory or how we interpret information. And so like if you accidentally set your lab bench on fire and destroyed your samples, sure, that is failed. But if it's just, you think you did the protocol, but you're not getting the results that you would expect, maybe that's only happened to you a couple of times, so you don't really know what's going on. But if you share what can happen.
Courtney, I suppose we've lost
How
your
many
voice.
times is this not working? And that.
I suppose we are losing your voice. It's breaking. So maybe until we figure out, or maybe Laurie, we could just go ahead.
Yeah. Okay. Is it better now?
Yeah.
Yes.
Yes.
But maybe do you want to go ahead, Laurie, since we're running out of time?
Oh, yeah. I think, look, whenever I talk about Science Matters publishing observations and going away from narratives, a lot of people tell me, don't we have already enough of literature in the scholarly space? There is this inundation of information already, and do you want to have more journals? Do we want to have narratives somehow make me assimilate a scientific information better, as opposed to just having these pieces of these observations as being pieces of the narrative? Now, I think that's why it's also extremely important for us to take some responsibility, and if it is not to publish almost everything that we do, but really replicate these experiments, both from the technical side as well as an experimental side, not necessarily just from the same bottle of the buffer 3 times, but really have that one takes its responsibility to do reproducibility already in the lab, and make sure that as much as we can, make sure that there is not much of a technical error, a deliberate technical error from our side. And that's what we call it as single observations that incorporate both not just the observation, but also it includes some amount of reproducibility from the author themselves. So I do feel that if we can avoid it, if we figured it out, the technical thing should stay, and we need to make sure that we can reproduce already in the lab before we publish, even if it is a minimal unit that we want to publish. But if it so happened that you made a mistake, I think it's absolutely fine. There are always versioning, and we all make mistakes, and it's always and science is the best self-correcting process, and we can contribute to the process.
Courtney, do you want to quickly run through what you were saying, because your voice is breaking?
Yeah, sorry, I was just saying that it can be very difficult to self-assess whether something failed for technical reasons versus, you know, something that you're missing in the mechanism, because we have these cognitive biases that can kind of play havoc with our interpretation of ambiguous information and our memories when we have motivations or hypotheses up front. And so, you know, obviously there are some examples, like your lab bench caught on fire and destroyed all your samples, where it's like, yeah, that's a technical issue. But there are a lot of these intermediate grounds where maybe, you know, you are trying something and you know it should come out, or you think you know it should come out X way, but it keeps coming out no results. If that doesn't get published, what that can do is it can make it really nearly impossible for science to self-correct, because we're only releasing a certain type of information. So I think releasing data and studies where things didn't turn out the way you thought they were, maybe you don't exactly know what's going on, but maybe you're seeing it sometimes, and that can be combined with other people who are maybe seeing it sometimes, and you can start to meta-analytically across a number of researchers start to say, okay, we sometimes do this, we sometimes don't. No individual person did it enough to try and figure out what's going on, but by pooling the data across all these labs, we can start to better investigate that.
Thank you very much. Since we are running out of time, I'd like to take this opportunity to tell that we will continue our discussion in Twitter using ECI Wednesday hashtag. Please send in your questions and keep this discussion alive. But I'd also like to ask the panelists final comments on a particular question about how to make sure that early career researchers or young researchers are not afraid to use these alternative publishing systems. How can we encourage them to use this more as a culture change is my short answer. Yeah, so I take that as your final comment.
An approach that we are trying is to start young. So, you know, a lot of us are very entrenched in incentive structures right now. So what we are trying to do is work with undergraduates who are just starting their scientific careers and, you know, inculcate these practices of open science, sharing your data, you know, units of productivity right now, then in their careers, when they're not worried about getting the right postdoc or a faculty position or industry job, but they're just in it for doing science and learning about science.
Yeah, I think it's really important to teach how to do this in undergraduate work and graduate work. You know, preparing a data set for sharing is not something that's often taught, and so there's a large pool of people who are like, I might want to do this, but I don't know how. So I have other things that I need to do. So the more that can be kind of included in graduate curriculum, so that one, people know how to do it, but also it normalizes it. It just says, this is how you do science, can really help to increase that behavior.
The one thing we should definitely do is really to, when we want to change something, and not only that we complain, and that's actually not a bad idea to start complaining, because then you identified the pain point that we want to change, and we all complain, which is pretty good, but then we have to move on. We have to participate. We have to not only resist, but we have to participate in the change process, and that's what we have to do. I understand that early career researchers might feel that, you know, I need to have one of these 3 star papers, but as Guruji has pointed out very rightly, that we have it's even when you take all these observations and you put a distribution, this forms a perfect Gaussian distribution, and the top 5% of the data is the ones that we publish in these narratives, and there's the rest of this data. Even in the same lab, we have so much data, and I think we should publish them. We should start publishing reproducible data observations that define, or they belong to reproducibility, confirmatory observation, contradictory observations. We need to publish often observations as well as negative observations. I think that's already a good start. You participate in the process for change, and don't worry too much that everything will go to Nature or Science or Cell. I can tell you it won't. It will, even if you have that 5% of the data, the rejection rates in these journals are enormously high, and so it's only logical that we don't go and then we think that there's going to be a unicorn data that will give us this career and etc. But we participate in this change process by publishing these observations that have a larger good, not just as an individual, not just for for my career, but also for the society.
Thank you very much. I'd like to close this by saying that we are the resistant army who are making progress with the culture change. And I thank all the panelists and the audience for joining us today. Thank you very much. We'll be also continuing the discussion over Twitter using ECR hashtag. Thank you, and have a nice time.
Thank you.
Thank you.
Thank you for having
It was great. It was great.